U.S. military's new laser cannon takes down Russia's S-400. The U.S. Air Force Research Laboratory, AFRL, operating under the Air Force Materiel Command, is at the forefront of advancing directed energy weapons technology through its Self-Protect High-Energy Laser Demonstrator, SHIELD program. This cutting-edge initiative focuses on developing a high-energy laser weapon system that can be integrated into a pod mounted on fighter aircraft. The goal of the program is to create a powerful defensive tool capable of neutralizing threats such as surface-to-air missiles, SAMs, and air-to-air missiles, while enhancing the operational capabilities of U.S. fighter jets in increasingly contested airspace. Directed energy weapons, DEWs, like the laser systems being developed under the SHIELD program, represent a significant departure from traditional kinetic weaponry. Instead of relying on physical projectiles, these systems use concentrated energy, such as lasers, microwaves, or particle beams, to disable or destroy enemy targets. The advantages of such systems include precision targeting, rapid response times, and minimal collateral damage, making them ideal for contactless warfare scenarios. This technology is expected to play a crucial role in addressing modern threats, with potential applications against fighter jets, vehicles, missiles, and optical devices. Under the SHIELD program, the U.S. Air Force aims to integrate a modern laser weapon into a pod structure that can be mounted on fighter jets. The laser would serve as a defensive measure capable of shooting down missiles traveling at Mach speeds. This capability could significantly enhance the survivability of aircraft operating in environments with advanced air defense systems. The system's ability to intercept and neutralize incoming threats mid-flight positions it as a revolutionary tool in the future of aerial combat. The development of the SHIELD laser system involves collaboration with several leading American aerospace companies. Lockheed Martin, known for its role in manufacturing the F-35 fighter jet, has been awarded a $26.3 million contract to design and build the laser. The beam control system, a critical component responsible for directing the laser beam precisely onto targets, is being developed by Northrop Grumman. Meanwhile, Boeing is tasked with constructing the pod structure that will house the laser and its supporting systems. This pod must accommodate the laser, beam control system, cooling mechanisms, and power supply, all while maintaining the structural integrity necessary for high-speed, high-altitude operations. The completion of the SHIELD pod structure, anticipated soon, will mark a significant milestone in the program. Its delivery will enable AFRL scientists and engineers to begin integrating the various subsystems, including the laser and beam control system, into a cohesive and functional unit. This phase of the program is critical to validating the design and preparing the system for operational testing. The strategic implications of the SHIELD program are profound. By equipping fighter jets with laser weapons, the U.S. military can address emerging threats in modern combat scenarios. The ability to defend against advanced missile systems, particularly in environments dominated by sophisticated surface-to-air missile networks, would provide a decisive advantage. Furthermore, the SHIELD laser system could pave the way for broader applications of directed energy weapons, enhancing both defensive and offensive military capabilities. The collaboration between Lockheed Martin, Northrop Grumman, and Boeing exemplifies the commitment of the U.S. defense industry to advancing cutting-edge technologies. Each company brings specialized expertise to the project, from laser development to beam control engineering and structural design. This integrated approach ensures that the SHIELD system is not only technologically advanced, but also operationally viable in demanding combat environments. While the SHIELD program is still in the development phase, its potential impact on the future of warfare is undeniable. Laser weapons represent a paradigm shift in military technology, offering capabilities that were once the domain of science fiction. As the technology matures, it is likely to play a pivotal role in shaping the dynamics of aerial combat and redefining the strategic balance in contested airspaces. The development of advanced military technology has always been a crucial aspect of maintaining a strategic advantage in global defense. One of the most significant advancements in recent years is the U.S. military's development of a new high-tech weapon known as the Self-Protect High-Energy Laser Demonstrator, SHIELD. This state-of-the-art laser cannon has been designed to counter and neutralize some of the most formidable missile defense systems in the world, including Russia's S-400 missile defense system. The introduction of the Shield laser weapon represents a significant leap forward in the field of directed energy weapons. These weapons utilize concentrated beams of electromagnetic energy to target and destroy enemy threats with precision and speed. The Shield system, in particular, is capable of shooting down advanced missiles, providing a powerful and effective defense mechanism against potential aerial threats. The development and deployment of this technology highlight the ongoing efforts of the U.S. military to stay ahead in the ever-evolving landscape of modern warfare. The Self-Protect High-Energy Laser Demonstrator, SHIELD program, led by the U.S. Air Force Research Laboratory, AFRL, continues to make progress toward its goal of developing a state-of-the-art laser weapon system for use on fighter jets. While the program has faced delays, important milestones are expected to be achieved in the coming months, with the final integration and testing scheduled for the near future. Key subsystems of the SHIELD program, including Lockheed Martin's high-energy laser system and Northrop Grumman's beam control system, are anticipated to be delivered to AFRL by July this year. Once these components arrive, they will be integrated into the SHIELD pod structure, a process that will allow the full system to undergo comprehensive testing. The first full system tests are slated for the fiscal year 2024, marking a critical step toward operational deployment. Lockheed Martin, as the prime contractor, remains at the forefront of this ambitious project, overseeing the integration and testing phases. Despite the progress, the program has encountered significant technical challenges, primarily due to the complexity of shooting down high-speed missiles in flight. These missiles, capable of traveling at speeds greater than the speed of sound, present unique difficulties for a laser weapon system. The laser must not only maintain precision, but also operate effectively under a range of adverse conditions, including high wind speeds, turbulence, and the rapid maneuvers of the aircraft carrying the weapon. These factors create significant disturbances and stresses, requiring innovative engineering solutions to ensure the laser can track and neutralize threats accurately. Jeff Hegemeyer, the SHIELD program manager, highlighted the complexity of these challenges, explaining the time and effort invested in solving them. He emphasized the environmental stresses that a laser system must withstand, such as turbulence and dynamic aircraft movements, while maintaining performance. These hurdles have contributed to delays in the program, but they are seen as necessary steps in achieving a reliable and effective system. The laser weapons system under development is expected to provide the U.S. military with a significant advantage in future combat scenarios. A primary focus of the system is countering threats posed by advanced surface-to-air missiles and SAMs, such as the Russian-made S-400 Triumph system. Fighter jets, particularly those operating in contested airspaces, face considerable risks from sophisticated SAM systems. The ability to intercept and destroy incoming missiles mid-flight would greatly enhance the survivability of U.S. Air Force aircraft, allowing them to operate more freely in hostile environments. The importance of the SHIELD program was further emphasized by Kelly Hammett, director of AFRL's Directed Energy Directorate, who described the system as a potential game changer. If the laser weapon performs as anticipated, it will enable fighter jets to neutralize missile threats in real time and operate in denied environments where traditional defense systems might struggle. This capability would solidify the U.S. Air Force's strategic advantage over adversaries by enhancing its ability to counter increasingly sophisticated air defense systems and other emerging threats. SHIELD program represents a critical leap forward in military technology, tackling complex engineering challenges to develop a laser weapon system that can operate effectively in dynamic combat conditions. While the path to achieving this capability has not been without setbacks, the anticipated benefits underscore the significance of this endeavor. By equipping fighter jets with directed energy weapons, the U.S. military aims to maintain technological superiority and enhance its operational capabilities in future conflicts. The Palletized High-Energy Laser (PHEL) system is another example of the U.S. military's advancements in directed energy weapons. Based on Blue Halo's Locust laser weapon system, the PHEL system has been deployed overseas to combat enemy drones and other aerial threats. This system has shown promising results in tests, further demonstrating the potential of laser weapons in modern warfare. The deployment of the P-HEL system marks a significant milestone in the development and operational use of high-energy laser systems by the U.S. Army. The strategic importance of these advancements cannot be overstated. The ability to deploy effective laser weapons provides the U.S. military with a powerful tool for defending against advanced missile threats. The SHIELD and P-HEL systems represent a significant step forward in the development of directed energy weapons, offering a new level of precision, power, and versatility in countering a wide range of aerial threats. The S-400 Triumph system, developed by Russia, represents one of the most advanced surface-to-air missile systems in existence. Designed to counter a wide array of aerial threats, including stealth aircraft, ballistic missiles, and drones, it has been a cornerstone of Russia's defensive strategy. The S-400 is equipped with sophisticated radar and missile systems capable of detecting targets up to 600 kilometers away and engaging them within a 400-kilometer radius. Its ability to track and simultaneously engage multiple targets across various altitudes makes it a formidable force on the battlefield. Nations such as China, Turkey, and India have procured the S-400, signifying its strategic importance. The United States, however, has been investing heavily in directed energy weapons, DEWs, particularly laser technology. Unlike traditional kinetic weapons, laser systems use focused beams of energy to disable or destroy targets. This approach offers several advantages, including near-instantaneous target engagement, precise strikes, and potentially unlimited ammunition, as long as power supplies are maintained. U.S. defense agencies, including the Department of Defense and DARPA, have made significant strides in developing these systems, integrating them into platforms ranging from naval ships to ground vehicles. Among the most promising developments in this domain is the high-energy laser, HEL, weapon system. These lasers are capable of neutralizing small threats like drones and mortar rounds, but recent advancements suggest the possibility of scaling up their power for more substantial targets. The HEL system's potential to counter sophisticated air defense systems, like the S-400, lies in its ability to deliver a continuous, high-energy beam capable of overwhelming or damaging critical components such as radar arrays and missile launchers. To understand how a laser weapon might counter the S-400, one must first consider the vulnerabilities of such air defense systems. The S-400 relies heavily on its radar and communication networks to detect and track incoming threats. These components, while highly advanced, are susceptible to interference or physical damage. A high-powered laser could, in theory, disable these systems by targeting their antennas, radar dishes, or optical components. By rendering the radar inoperative, the S-400's ability to identify and engage targets would be severely compromised. The U.S. military has tested various laser systems that could potentially fit this role. For example, the AN/OSEQ-3 laser weapon system, LAWS, was deployed aboard the USS Ponce in 2014, marking the first operational use of a laser weapon. More recently, the Helios, high-energy laser with integrated optical dazzler and surveillance system, has been integrated into naval operations, showcasing its ability to engage and neutralize small-scale threats. While these systems are primarily designed for defense against drones, rockets, and small boats, the underlying technology could be adapted for more complex engagements. However, deploying a laser weapon capable of neutralizing the S-400 is not without challenges. One significant hurdle is the power requirement. High-energy lasers demand substantial amounts of electricity to maintain their beams, which necessitates advanced power generation and storage solutions. Additionally, atmospheric conditions, such as rain, dust, or smoke, can diminish the effectiveness of laser beams by scattering or absorbing their energy. Overcoming these limitations would require innovative engineering solutions and operational strategies. The geopolitical implications of such a development are profound. The S-400 has been a point of contention between Russia and NATO-aligned nations, particularly with Turkey's acquisition of the system, leading to strained relations with the United States. The hypothetical deployment of a U.S. laser weapon capable of neutralizing the S-400 would signal a significant shift in the balance of power. It would not only undermine the strategic advantage provided by the S-400, but also potentially provoke an arms race in directed energy weaponry. Critics argue that such developments could escalate tensions between major powers, increasing the risk of conflict. The deployment of advanced laser systems might be perceived as a direct challenge to the deterrence capabilities of rival nations, prompting them to develop countermeasures or similar technologies. This dynamic could lead to a new era of military competition, reminiscent of the Cold War arms race. On the other hand, proponents of directed energy weapons highlight their potential to minimize collateral damage and reduce the costs associated with traditional munitions. Laser systems offer precision targeting, which could limit the unintended consequences of military engagements. Moreover, their scalability and versatility make them valuable tools for a wide range of scenarios, from defending critical infrastructure to supporting ground operations. The idea of a U.S. laser cannon disabling this formidable system revolves around exploiting the vulnerabilities inherent in any complex technological infrastructure. The S-400 relies heavily on its radar arrays and communication networks to detect and track targets. While these systems are highly advanced, they are not invulnerable. High-energy lasers, HELs, with their ability to deliver a continuous, concentrated beam of energy, could potentially damage or disable critical components of the S-400, such as radar dishes or communication links, rendering the system ineffective. This potential stems from several key advantages of laser weapons. Unlike traditional kinetic systems, which rely on projectiles to destroy targets, lasers deliver energy at the speed of light, allowing for near-instantaneous engagement of targets. This makes them particularly effective against fast-moving threats or systems that require real-time responses. Furthermore, lasers provide pinpoint accuracy, minimizing collateral damage and ensuring that only the intended target is affected. They also offer a cost-effective alternative to traditional munitions, as their ammunition is essentially unlimited, constrained only by the availability of power. In recent years, the United States has made significant investments in developing and testing directed energy weapons. Systems like the Iran CQ-3 laser weapon system, LAWS, and Helios, high-energy laser, with integrated optical dazzler and surveillance, represent the forefront of this technology. These systems have been deployed and tested in real-world scenarios, demonstrating their ability to neutralize small-scale threats such as drones, rockets, and mortar rounds. While these systems are currently optimized for defensive applications, their scalability suggests the possibility of adapting them to engage more complex targets like the S-400. One of the most critical challenges in this hypothetical scenario is the power requirement for a laser capable of neutralizing the S-400. High-energy lasers require substantial amounts of power to generate the focused beams needed to damage or disable advanced systems. This necessitates advanced power generation and storage solutions, which are still areas of active research and development. Additionally, atmospheric conditions such as rain, fog, or dust can attenuate laser beams, reducing their effectiveness. Overcoming these challenges will be crucial for deploying laser weapons in diverse operational environments. The geopolitical implications of such a development are profound. The S-400 has become a symbol of Russia's technological prowess and a critical component of its defense strategy. A U.S. capability to neutralize the S-400 using laser technology would not only undermine the perceived invulnerability of the system, but also challenge the strategic balance between the United States and nations aligned with or dependent on Russian military hardware. This could lead to increased tensions and potentially spark a new arms race focused on directed energy weapons and countermeasures. Critics of directed energy weapons argue that their deployment could escalate global tensions and destabilize international security frameworks. The perception of such technologies as offensive rather than purely defensive could provoke adversaries to develop their own DWs or other advanced systems, fueling an arms race reminiscent of the Cold War. Additionally, the integration of directed energy weapons into military strategies raises ethical and legal questions about their use, particularly in conflicts where civilian infrastructure might be affected. Despite these concerns, proponents of laser weapons highlight their potential to revolutionize military engagements while reducing the human and economic costs of warfare. Laser systems, with their precision and scalability, could significantly reduce collateral damage and unintended casualties in conflict zones. Their ability to neutralize threats without explosive impacts makes them particularly valuable in urban or densely populated areas. Furthermore, their versatility allows them to address a wide range of threats, from intercepting incoming missiles to disabling hostile surveillance systems. The trajectory of technological advancement suggests that laser weapons will continue to evolve, addressing many of the current limitations and unlocking new capabilities. The integration of these systems into existing military platforms, such as ships, aircraft, and ground vehicles, is already underway, signaling their growing importance in future military strategies. As these technologies mature, their role in shaping the strategic calculus of modern warfare will become increasingly significant. For the U.S. military, directed energy weapons represent an opportunity to maintain a technological edge over potential adversaries. The development of laser systems capable of countering advanced air defense systems like the S-400 would not only enhance the United States' offensive and defensive capabilities, but also reinforce its position as a leader in military innovation. This could have a cascading effect, influencing the strategies and investments of allied nations and potentially reshaping the dynamics of international security alliances. While the idea of a U.S. laser cannon neutralizing the S-400 remains speculative, it serves as a powerful illustration of the transformative potential of directed energy technology. As these systems become more advanced and widely deployed, they will undoubtedly play a pivotal role in the evolution of military doctrine and the nature of conflict. The question is not merely whether such a scenario is possible, but what it signifies for the broader landscape of global security and technological competition. The narrative of a U.S. laser cannon neutralizing the S-400 encapsulates the intersection of technological innovation and geopolitical strategy. It underscores the transformative potential of directed energy weapons while highlighting the challenges and implications of their development. As nations grapple with the complexities of modern warfare, the pursuit of technological supremacy remains a defining characteristic of the global security landscape. The question is not merely whether such a confrontation is possible, but what it signifies for the future of conflict and deterrence. We'd love to hear your thoughts on the revolutionary SHIELD laser weapon system and its potential to redefine modern combat. Do you think this technology could truly give the U.S. Air Force a decisive edge? Share your insights in the comments below. If you found this breakdown of cutting-edge military advancements fascinating, don't forget to like, share, and subscribe for more deep dives into groundbreaking innovations. Thanks for watching and stay tuned for more exciting content.